Good afternoon. Good afternoon, Mike. Hold on, thank you for everyone that attended the conference. We thought we'd do something a little different this year and offer a more in-depth training session overview, something more technical for a lot of the techies out there. And started talking with some of our vendors, Copper River, as well as ADVA Optical and Juniper, for some different ideas of what we could do. And with SDN being the big buzzword out there, wanted to teach people more about it. How could they use it? How's it being used from other networks? And Chris Cole from Copper River told me about some exciting stuff that was going on at Marist College, and talked about it a couple times, got on a WebEx, saw what they were doing, was extremely excited about it. I looked at what they were doing and said, let's start putting it on the network, and kind of got pushed back and said, whoa, this isn't ready for production yet. But it's a great idea of what's going on in the environment right now, and getting people to use the technology and getting the collaboration going and working together to really see what's available in cyberpunk networking. So I'll kick it off and introduce Todd Bundy from ADVA. One thing I'll say, as you're watching the presentation, think about what KINBER's role and what we can do on the Penryn network with this, because there's an opportunity to take what's being done here, what we see today, and replicate it across our network and really involve our members. I think both from a IT staffing perspective and further down into the universities, and get it into the students and the professors that are doing this on their level. So think about that as you're watching the presentations, and afterwards we'll talk about some potential use cases, how to develop this sandbox across the network, and how we're going to go from there. Thank you.
So my name is Todd Bundy from ADVA Optical Networking. I'm the Director of Business Development. So I've been working with Kazimir Dikusatis here from IBM for probably about 8 or 9 years now. He is their top expert worldwide in optical. We do a lot of mainframe clustering, server clustering, and he came to me about 2 years ago and said we're doing this kind of interesting test bed at Marist College. And we talked about the fact that they were going to virtualize layers 2, 3, automation right up through layer 7, and I said, well, our guys have come up with a very unique solution that virtualizes layer 1. And I was like, well, virtualizes layer 1, meaning we can actually bring up and down wavelengths on demand from an SDN controller through our own network hypervisor. And that's very unique in the industry, because if you look at every other optical vendor, they're going in a completely different direction. They are not providing wavelengths on demand in the way that we are through an SDN controller. And they certainly aren't orchestrating layers 1 through 7. It's one thing to come in at layer 1 and say, yeah, I'll give you some wavelengths on demand, but orchestration of the LAN switches, all the way up to the application is what we're going to demonstrate for you here today. The other great thing about this, and I'm just going to repeat what Mike was saying, was this has been really great for the students at Marist College. They've gone to, we've got a couple here today with us that Robert will introduce, but they've gone to a lot of these different Internet 2, all the different conferences. They've been over to Europe, the SDN Congress. We've had Morgan Stanley and all these customers come up to Marist College. The students got to meet them, and of course, they gave them their cards, and of course, they've all got jobs before they're sophomores. So the most important thing here really is the students. How do we get KINBER to copy what Marist did, create an SDN testbed, use our technology, and use all this free open source software to orchestrate this? Okay, because the difference with our solution is that once you have our hardware, it's all free software on top of that to make it all work. And that's different than where other vendors are going, where they want to charge you for an SDN controller, they want to charge you for the software. we're saying there's a much better way to do this. And believe it or not, the best software coming out of the industry right now is coming out of the schools. It's coming out of students like this that have no baggage, they're open-minded, very creative, and we create some great solutions. So with that, I'd like to introduce Kazimir Dikusaudis of IBM to kick this off. Thank you.
Thanks, Todd. Good afternoon, everybody. My name is Kazimir Dikusaudis. I'm an IBM Distinguished Engineer based up in Poughkeepsie, New York. And what I'd like to do this afternoon is give you a little bit of a tutorial and introduction to how we use SDN and NFV in next generation networks, how we put that together to create what we call a software-defined environment, and then how we built that environment at places like Marist College and the New York State Cloud Computing Center. I'm going to start off with a little bit of motivation as to why IBM, ADVA, Marist, and a lot of other companies are interested in this work, and why you should be interested in it too. I'm going to do a quick tutorial without spending too much time. How many folks here are familiar with OpenFlow, if I could ask? About a fair amount of folks, a little over half the group. Okay. How about OpenStack? Who knows what OpenStack is? A couple of folks? Okay. So I'll try to give an appropriate level tutorial on what those things are and how they fit into the big picture. Then I'm going to talk a little bit about our approach, which, as Todd said, is based on free open source software and industry standard hardware and protocols. And then I'm going to hand it off to the team from Marist to take you through a little bit of a deep dive on what we built over the past 2 years and what we have running right now in both their research and production labs. So I think this is a really exciting time to be involved in data networking. The industry is going through one of the major changes that we've seen in our lifetimes, the sort of thing that comes along once every few decades. We've seen transitions from mainframes to client-server environments, and now we're seeing a change in the way people buy and deploy their IT resources. It used to be that your data center environments were static because your workloads were static. Nothing changed over time. The devices that you bought, computers, networks, storage, were the same devices regardless of what application you were trying to run, because the application and the underlying infrastructure weren't related in any meaningful way. In environments like this, things don't change very much. So we can get away with having manual configuration. Skilled technicians who've taken certifications from a bunch of different companies that spend a lot of time making sure that the system does what you intend. And those people are vital because they take your business requirements and translate them into commands that they can type into a management interface to make the data center behave. All of that is starting to change. And according to people like Gartner Group and Del Oro, it's probably going to go away in the next couple of years. Why? Because workloads are starting to change. The workloads that we're seeing now are not static for the most part. We're seeing a lot of mobile computing, a lot of social networking, a lot of big data and analytics. Video streaming is huge right now. Half the internet traffic in North America is video from people like Netflix and YouTube. These kind of environments, the network has to behave in a different way. You're bringing connections up and down, changing the routing, bringing in high availability or not high availability as the case may be. The whole thing is more agile. It's more flexible. And it has to scale to much larger levels than it ever has done before. Warehouse scale data centers that are being run by IBM SoftLayer, Google, Amazon, Yahoo, name your favorite cloud provider. So as the applications change, the IT environment has to change along with it. And what we're seeing is a much greater emphasis on using software to control all the aspects of your data center. Back in the early 1960s, IBM pioneered virtualization on the mainframe. The idea that you could have one physical server that would be serving many logical or virtual clients off the same device. Now we're seeing that same principle applied to the whole data center, including networking and storage. We're seeing dynamic, workload-aware appliances. You can't run a warehouse scale mega data center with manual provisioning. So you need to automate a lot of the things that are done manually today. And when you do that, you need to have an open API that lets you program things right down to the lowest levels of the infrastructure. So in this kind of a world, we're addressing a lot of pain points that people have struggled with for many years. Today, if you try to provision an end-to-end flow across your data center, a server, a firewall, a load balancer, some other optimization appliances, finally to another target at the other end, if you have someone who knows what they're doing and you have the time and the resource, it takes you about a week to do that. It can take 3 or 4 days to spin up just a firewall or a load balancer. And a lot of that is manual provisioning time. It's a limitation of the technology. If you're trying to do this across a wide area network, across hundreds of kilometers or more in a metropolitan area, it's going to take you weeks or even months. There was a major hurricane that hit the northeast coast of the U.S. about a year and a half ago, Hurricane Sandy. Right? It almost took out the Verizon data center in northern New Jersey. Because as the hurricane hit and the floodwaters started to rise, they protected their data center using a very high-tech technology called sandbags. If we had gotten about 6 more inches of rain, we would have lost the Verizon POP in northern New Jersey. You can look up the Wall Street Journal articles that they published with pictures of the data center with water on the floor. And you may say to yourself, why didn't Verizon just move all that data somewhere else? Well, you can't re-provision the wide area network in less than a couple of weeks. Last I heard, we can't do accurate weather forecasting that far in advance. What if your data center was agile enough that you could nail up wavelengths on demand across the metro and move everything a few hundred miles inland when you heard a storm was coming? The first people to offer that in the New York City metro area are going to be a game changer. The first people to offer it in Pennsylvania are going to have a unique service in the country. That's the kind of thing that drives differentiation and economic growth. These programmable networks are more agile, which also means you don't have to over-provision everything. Today, if I put a service in place, I have to provision to the peak workload. I have to assume that there's peak workload running all the time because it takes me so long to change things. So that means I've got a lot of capacity sitting there idle most of the time. Servers, storage, network bandwidth is stranded. I can't use it. In a more agile, dynamic environment, I don't have that problem. I can provision for average workload instead of peak workload. That makes a huge economic difference. And of course, I can offer new services because I can re-provision quickly. Maybe Facebook wants to offer a special deal on Friday afternoons to get new customers to sign up. They can change their website in a matter of a few minutes. They can't easily reconfigure the network that's feeding all of those mobile devices into their mega data center. These are the kind of obstacles that we're trying to overcome. Faster provisioning, new service offerings that generate revenue, and solutions to problems that have plagued us for a long time. Now we know this works because we've seen it work for server virtualization. This is some data from a study that IBM did back in 2012. Major New York City financial client, Wall Street data center, that was getting about 10% utilization on all of their servers. This is the old traditional way of provisioning your systems. We went in and analyzed their workload, and we determined there was about a dozen variables that made a real difference in how much CPU utilization they were experiencing. Based on that, we were able to write a software policy and use some analytic models to predict future demand based on what was happening currently. Doing that allows us to quadruple their utilization. Goes up to about 40%. You save a ridiculous amount on hardware because you don't have to buy new servers. Your operating costs are cut in half because you don't have to manage a lot of new stuff. It easily pays for itself in less than a year. So if recovering stranded bandwidth through virtualization is such a good deal on the server, why don't we do it on storage and on networking, on every other aspect of the data center? Well, we try to. And storage isn't doing a terrible job. They're reasonably well virtualized. Servers are probably the best of all, but the network is currently our big bottleneck for realizing these kind of savings. I put a quote up on this chart from one of my colleagues at Cisco, just to reinforce the point I made earlier, that says, if you want to provision an end-to-end service in a multi-tiered network, today it takes them about a week to spin that up. Their goal is to get to less than a day. Meanwhile, I can provision a new virtual server in a matter of about 5 or 10 minutes. There's a serious mismatch between virtualization on the server and the rest of the network. That's why the industry is so excited about SDN and NFV, because we see it working on servers, we know there's a gap. It's pretty straightforward to say, if I can apply these same principles, there's a lot of leverage to be gained. Now, when people talk about this area, they'll throw around terms like cloud computing and SDN and NFV without really defining them. And I'll bet anybody in here a cup of coffee that you can't find a major vendor in the industry who says they're not doing SDN. Because I guarantee you that whatever they're doing, they'll put a label on it and say, this is SDN, because it does that. Well, let me try to step back from that a little bit. I'm a big believer in open industry standards and open source software. So when I talk about SDN, I'm talking about separating the control plane and the data plane on your switches. Today, if you buy a switch from anybody in the industry, I don't care who it is, Cisco, Juniper, Brocade, Huawei, IBM, take your pick, you're going to get a shrink-wrapped box that runs its own copy of the network operating system. It has about a couple of 100,000 lines of spaghetti code in there written by that one vendor. You have to take a certification course and become an expert in how to provision that box in order to make it work properly. You have to run multiple copies of the operating system at every node in your network, and you don't have visibility more than one hop away. SDN addresses that by having a centralized control plane. So the switches do what they do best, move bits around really fast. The controller gives you an end-to-end view of everything that's going on. Now, once you've done that, you've set the course for virtualizing a lot of functions that today are done in physical boxes. NFV, Network Function Virtualization, is a standard that was first developed by the telecommunications industry, but similar things are happening in the data center as well. You replace your physical boxes with software. So instead of buying a firewall as a box that has a power supply and a fan and its own operating system and everything else, you buy a set of code that does that function, and you install that on a server of your choice. x86 power, mainframe, doesn't matter. This gives you tremendous cost savings up front. It also allows you to reconfigure that dynamically, because those NFV devices can be chained together using your SDN network. So this leads to the idea of SDN networks being application aware. Traditional data center environments, one switch doesn't know anything except what's one hop away from it on any side. In an SDN environment with centralized management, we can set up and control end-to-end flows in the network. And we can also make sure that application policies on bandwidth, availability, latency, and other things get translated directly into provisioning of the network. Okay? One of the analogies I like to use is it's like the difference between driving your car with a paper map or a satellite navigator. How many folks have satellite navigation systems in their car? A couple? What are the rest you're waiting for? This is great. This is amazing stuff. I mean, if I have a paper map that I get from the auto club, I'm looking at a snapshot that was taken at some time in the past. It's static. I have to manually read this thing. If I put it on the seat next to me, I have to keep looking over at it. Nobody tells me what to do. If I have a navigator, I can see my whole route end to end before I pull out of my driveway. It's updated dynamically. I know if there's a traffic accident or if there's congestion or road construction, and I can pick another path to go around it. I can put it on the seat next to me and forget about it, and it'll call out turn-by-turn directions of what I have to do to navigate from one place to another. That's the difference of centralized control, a satellite that sees the whole world, versus these static maps of your network that are very old. And by the way, once I can do dynamic control, now I can do dynamic quality of service. So maybe there's some times a day when I want to avoid the freeways because there's a lot of congestion. Maybe there's times of day when I want to stay away from the schools because they're just letting out and there's buses on the roads. With a centralized controller, I can do that. Not so much in today's environment. So SDN is nothing more than saying I take a traditional switch, I separate the control, the management, the security, the flow tables, and I put that into a piece of software that runs on a cluster of servers for high availability. There's a protocol called OpenFlow that talks between that controller and all the switches in your network. Industry standard protocol, so as long as your boxes speak OpenFlow, your controller can tell them what to do. All the flow tables sit in the controller, so I do physical flow control. I can take packets that go in port number 3 on switch 12, you're supposed to go out port 5 on switch 12. So physical flow control is great, but that's not the whole story. SDN also allows virtual flow control. What do I mean by that? In the same way that I can take a physical server and carve it up into a lot of different VMs, I can carve up my network into a bunch of different virtual overlays. I can virtualize all the layer 2 and 3 addresses and abstract them from those boxes. This example is using an IETF standard called DOVE, Distributed Overlay Virtual Ethernet, to slice up my physical network into 3 different virtual overlays, all logically isolated from each other. The isolation goes all the way back into a virtual switch running in your server hypervisor. IBM's implementation of that is a product that we call SDNVE. And one of the nice things about this is when you virtualize the network, you can build in connectivity services. Now this is kind of like a DNS server for your data center. A DNS server maps IP addresses to URLs. In the same way, these overlay networks can map virtual machines into virtual overlay networks. So I made an analogy to the post office for people who still send letters in the mail, paper letters. If you want to send a letter to somebody, you put it in a packet, you look up their address in a directory, you drop it in a mailbox. After that, the delivery is done in a cloud. You don't know if it's getting delivered by a truck, an airplane, a pack mule. Eventually it gets to the other side. Now, if you're sending a letter to somewhere like the Pentagon, we don't deliver that mail directly to some general's office. We send it to a mail stop for security inspection. You open the envelope, you check for ricin and anthrax and bombs and all sorts of good stuff. And if it passes that security check, then you send it along. We can do exactly the same thing with our virtual networks. The overlay network comes with a directory service that maps all of the virtual machines on the server into their own isolated overlay networks. So I'm sharing the underlying physical infrastructure with a bunch of virtual overlays. I'm only allowing packets to flow through their own virtual network, so they're isolated. I can put virtual firewalls, load balancers, and other NFV appliances in that flow dynamically through my central controller. So now I can decide where I want the firewalls, what the rules are going to be, just as I would if it was a physical delivery system. Now you combine all that together, physical and virtual flow control, and you've got some pretty powerful tools. There's a lot of companies working in this area. As I said, I'm a big proponent of open industry standards. So the controller that I like to reference is Project Open Daylight. This is something that the Linux Foundation launched about a year or so ago. Same people who brought you the Linux operating system for servers are doing the same thing for the network. There's a lot of companies involved and a lot of private developers. Their first official release, called Helium, just came out in the fall of last year. So for free, you can go to opendaylight.org, download a controller that speaks OpenFlow and Dove, and also a bunch of other things I didn't talk about, like BGP and MPLS. And you can use that to provision your underlying physical network as long as the network supports open industry standards. It feeds into the back office management and billing systems as well. So I can do differentiated quality of service with differentiated billing. If I apply this inside the data center, then I'm essentially creating abstractions of all the boxes that are sitting on my data center floor. And I can write application patterns that tell me what I want to do. So today, if I want to do credit card processing, I'm a big bank, I'll have to write my own application from scratch. I'll have to own that, maintain it, and update it year to year. In this environment, I can go to the equivalent of an app store and download a standard profile for credit card processing, and then customize it the way I want through these open APIs. So it gives you tremendous flexibility that you didn't have before. The way we realize the rest of the stack is through a cloud computing approach to infrastructure as a service that we call OpenStack. This is, again, open source software. So OpenStack is the cloud middleware. It has three interfaces, Nova, Quantum, and Cinder, that control the servers, networking, and storage. So the controllers for the network that I spoke of, Open Daylight, sit underneath the Quantum interface. There's similar hypervisors for servers and storage that I'm not going to go into right now. OpenStack brings all that together and lets you provision the whole software-defined environment, or software-defined data center, as some people call it. This is a completely new set of features and functions that we've never had before. And we're proposing that you can extend this function outside a data center, use it across a metropolitan area network to tie together multiple data centers. So my infrastructure as a service extends to cloud environments, cloud bursting, multiple data center connections. This is a very, very fast-growing area. In the past year, they've gone from having maybe 100, 150 contributors to having tens of thousands around the world. We could easily stand here and spend a lot of time talking about all the open software interfaces in OpenStack. I don't have time to do that. But using this, we can make connections between the application and the infrastructure. So if I have an application that needs low latency, I'm not relying on a human being to figure out what that means and manually provision 100 switches. I can do it automatically through this open API. And I can run the same conditions on the servers and the storage. Opens up vast new areas of application that we just simply could not do before. Now, we've been investigating some of this at the New York State Center for Cloud Computing. You're going to hear a lot more about that in just a minute. This center was established at Marist College in Poughkeepsie, New York, to help investigate applications of software-defined environments for commercial applications. IBM is one of the founding members and sponsors. You can see some of our other partners up there, including ADVA, NEC, Big Switch, and many others. We also have the mission for the state of New York of driving cloud computing and analytics research. So we have partnerships with private universities like Columbia, public schools like State University of New York, urban campuses like City University of New York, and a couple of others, which help us to drive a unified research agenda. I'm going to give you a quick sneak preview of this, and then I'm going to let the team from Marist and some of the students get up and tell their own story, because we're very excited about this. We've built a test bed with 3 data centers, all filled with different types of servers and networking and storage. Mainframes, x86, IBM Power Blades, all types of Ethernet switches, all interconnected with a 100-kilometer metro optical network provided by ADVA. All of the boxes in this system are run through a centralized SDN controller. And we've tested several different types, including Open Daylight, something called Floodlight, and several others that you'll hear about in a minute. We're also running that virtualization protocol that I spoke of, SDN-VE. So, without stealing too much of their thunder, let me give you a little taste of what's coming next. We can monitor any server in this system. We can look at the CPU utilization, physical and virtual memory, and a lot of other attributes. We can run virtual applications on that server, like video apps. If we decide that that server is getting overloaded, it can't handle the workload, then we can make a decision to move that workload somewhere else. All this is automated and pre-programmed. It requires no human intervention. So if you detect that something is happening, you do some analytics and decide where you want to move things and how much bandwidth you need to move them there. Once you make your decision, you provision the switches in the source data center, the target data center, and the optical transport all at once from a single controller. That's the operation that I told you before currently takes 5 days if you're in one data center, 3 weeks across the WAN. We can do it across the WAN in about a minute. You nail up wavelengths on demand, you build virtual overlays on top of them, then you move the virtual machine live migrated from one place to another. Live migrate means the application keeps running as you move it. You can continuously ping the VM, and you've got no idea that it's moving. You only miss maybe 1 or 2 out of every 100 pings. Once it gets to the other side, and it's running safely, your end user doesn't know anything's happened. And you can decide what you want to do next. In our case, we decided to revert the network back to the way it was and wait for the next change. Just for fun, we put a management and control interface on a wireless app, so you can run this thing off your tablet or your smartphone. So the next time a hurricane hits the East Coast, your first thought should be getting yourself to safety and to higher ground. As you're walking out to the parking lot, you pull out your smartphone. You log into your data center. You do one-click provisioning and tell it, invoke disaster recovery protocol. The system automatically nails up wavelengths across the WAN, reconfigures all the network, dumps all your data a few hundred miles away to where it's safe, keeps the apps running while it's doing it, and then reverts back to the original configuration. And it's continuously sending you alarms, alerts, and messaging on your mobile device so that you know what's happening. There's nobody out there today who can do this. That's why we got written up by the blog for the Wall Street Journal. We've been in Light Reading, AP Wire Service, Network World, and a whole bunch of other things that are referenced on this slide. We're very excited about this. My last point is that we're not just doing this as an academic research exercise. That's exciting enough. We're going to talk at IEEE Cloud Symposiums, Internet 2, SDN World Congress, and so on. But we're also bringing in clients that ADVA and other sponsors have brought to us to show the practical value of this. Marist was named as the New York State Center for Cloud Computing because they want to use this as an engine to drive economic growth in the state of New York. So we're talking to Fortune 500 banks, JP Morgan Chase. Morgan Stanley's been up to see us twice. Last time was about a month ago. We had 25 general managers from Bank of China come to upstate New York to talk to us about this. ESPN heard about this last year when we gave them a preview of what we were doing before it was fully baked. The ESPN people have data centers in Connecticut that live stream events like Wimbledon and the Super Bowl down to the Jumbotron in Times Square in Manhattan. They want a live streaming video application that does exactly what we were doing. The ESPN guys got up and spoke to us afterwards and said, this is a capacity we've been waiting for a very long time. To dynamically reprovision my network and to be able to provision to average instead of peak workload delivers huge value to these people. We're talking to telecom, cloud, and service providers. Verizon here in the US, Docomo and KDDI over in Japan, Deutsche Telekom in Germany, and others. A little later, the Marist team is going to talk about some work they did with CERN research labs in Switzerland. CERN took this work modified it a little bit so that it would deal with their particular workloads, which is high-performance computing and gigantic data sets. And then they took it along to show at Supercomputing 2013, to show how we can customize network provisioning for real-world applications. So we have a test bed that's not just for research. We're using this as a proof of concept center for major industry clients who want to get their feet wet with SDN and NFV and want to learn how to orchestrate the whole stack and the whole infrastructure in the cloud. It's a really exciting time, as I said at the beginning of the talk. And before I hand this over to the Maris team, I want to remind you that this is all about open collaboration and open standards. So myself and the rest of the team are very open to working with other universities, other companies, other institutions that share our passion for SDN and NFV and would like to bring their applications into our test bed, or take the principles that we developed in our test bed and implement them in KINBER or other systems. We know it works already. Now we're trying to spread the word and help people take advantage of all of this. So let me pause there for a second and see if there's any questions or comments on what I just said before I hand it over to the team from Maris. On that side, we also have two of our award-winning students who we're very proud of that have written all of this code and done the actual testing. So I'm not going to take credit for sitting in the data center and doing all of this. I want to make sure that they get recognized for that. And they're going to tell you a lot more detail about this really exciting work that we have and how you can apply it to KINBER. So, Rob, can I hand this over to you?
You're already on the desktop, right?
Just out of curiosity, how many folks heard of Maris College before we came in here today? Anybody? And how many of you follow women's basketball? There you go. I thought so.
Are we going to pick up UConn here or what?
I'm just saying that before we became the world's center for SDN research, Maris was also known for having a women's college basketball team that consistently made the Final Four and has won the championship a few times, I believe, in past history. So if you're not a women's basketball fan, you may not have heard of us before this, but I think we're going to give you good reason to pay attention going forward. So Rob?
Great, thank you.
Away.
I don't typically stand in one spot to present, so if I start to walk around and I don't have the mic, hopefully I'll speak loud enough. So thank you very much for the wonderful introduction, Casimir. So the topic of today, as my understanding proceeds, is we're really trying to develop a new approach for developing technology and really building partnerships here. Okay, so that's not just true to our SDN Innovation Lab at Maris, but that holds true to SDN, OpenFlow, and the whole NFV concepts in trying to build and develop these technologies at more of a rapid pace than we've done so in the past. And so I want to take a some brief time, and I want to go through kind of the evolution of how this Innovation Lab started and its inception, and we'll walk through a couple different projects that we've gone through, and then we'll walk through more about the innovative and dynamic infrastructure that more or less we've done with ADVA and IBM. So this is the Innovation Lab team here. There's currently 3 faculty, including myself. There is the production network staff, so this is on the production network, and then we have a multitude of students that are either undergraduate information technology and systems students, computer science students, and then we currently have one graduate computer science student as well. That's unfortunately is not listed on this slide. And so, former students. Now, this is where I get to tout my former students, right? Because you see, two students standing up here right now, Mary and Zach, have done the bulk of the development for Avalanche, which you'll see in a little bit. But these students, so myself and Ryan Wollner started this program along with Casimir and at Marist. And it got to the point where after the initial funding, I said, that's great, we got this initial funding. Ryan, go out and do some research on this. And he'd come back, a couple days later and say, I found this really great stuff here. Oh, okay, let me see what you have. Okay, keep going. And push him off to the side. He'd come back a couple days later. Oh, I have more, this is really great stuff. Yeah, keep going. About 2 to 3 weeks into this, where I kept saying, keep going, I finally said, you actually have something here. All right, now let's proceed together here, and let's see where this takes us. And so you'll see with the evolution of projects, and you'll see with the current list of students that these students have graduated with either graduate degrees or undergraduate degrees. The research that they've done is more along the lines of PhD research and graduate research, which is phenomenal for undergraduates to be a part of. But they've gone on to companies like EMC, Big Switch, Amazon, IBM, USAA. Big companies, small companies, depending upon the individual. And so Mary and Zach, as I'm sure they will talk to you later about, but I can't keep these students long enough. So I keep them about a year, and they're getting scapped up by all these companies. So Mary and Zach are actually interning at Goldman Sachs this summer. So I lose them in the next month, which I'm very, very sad to say, but happy for them. So this is really about partnerships, okay? It's about building partnerships. It's about fostering collaboration. So currently, the Marist SDN Innovation Lab partners, IBM is actually a big partner since it's one of the primary partner that instantiated this endeavor. NEC, Big Switch, ADVA, Plexi, Sienna, Lenovo, and others who, for whatever reason, would prefer not to be listed. So we'll keep that to them. Casimir also mentioned other academic members, and so we've worked with Caltech, we've worked with CERN, we've worked with Columbia, New Paltz, CUNY, and NYU, and we continue to foster these collaborations as well. And they all bring different pieces to the puzzle, different types of expertise to the puzzle that we can really foster a great collaboration on. And so, who is Marist? Well, I saw by a show of hands that some of you are familiar with Marist, which is great. We actually do have the Marist poll, which some of you might be familiar with as well. But just a quick brief blurb on Marist. What we do at Marist is really try to develop that intellect and character at an undergraduate level. It is a small liberal arts college with a very, very strong technology focus. And you'll see in actually the first slide, there was a huge building that was just built about, I think it was about 3 years ago now. And that was really a new technology center that is now the Hancock Center. And that's where the School of Computer Science is housed, the School of Math. We have other wonderful facilities as well. So it's a small liberal arts college. Again, there's about 6,000 students in total there for graduate and undergraduate. And we have all sorts of degrees. As you can see from this profile, it's one of the best 377 colleges as of 2013, and we've been named ranked number 8 of colleges and universities in the northern United States, et cetera, et cetera. So a lot of people can't say enough good things about Marist, and I can't as well. So Casimir mentioned something very important here, the New York State Center of Excellence for Cloud Computing and Analytics. And so Marist received a $3 million grant as part of building out this excellence center, this cloud computing center. And so what we've done is to foster, again, collaboration and build economic growth in New York State by building up this cloud computing center to foster these and nurture these companies and get them to a point where we can actually let them go. So there's an incubation center in there to foster that collaboration, foster new business, and to provide that economic growth back to the industry. This was awarded in December 2012. Student research is a huge portion of this, and workforce development is really a big portion of this as well. So let's step back for a second. The IBM and Marist joint study relationship, this dates back to 1988. Okay, so what this is really a partnership that supports different disciplines and to build different academic careers. But it builds and participates on research, teaching and learning, and scaling operations and efficiency. And so this goes back to 1988, but really the important part that we're discussing today is this innovation lab. And we received the initial funding from the IBM STG University Alliance team in fourth quarter of 2011. And we actually just received some more funding from them for some of the great work that we've been doing. And so in that initial funding, there were really three objectives, all right? One was to, obviously, to complement the IBM Software-Defined Networking Research and Development Center. The next one was to establish a pipeline of skilled students. And the third was to actually give back to the community, all right? Give back to the open source community, give back and foster collaboration. And as of a year after that initial funding, we were actually proud to say that we successfully completed all of the initial objectives. There's a huge list of SDN project accomplishments here. This is just a few that I'll run through. And I won't really talk about these. I'll just kind of show this slide and we'll go into a little bit more detail in a little bit. But as you can see, this is anywhere from presentations to papers that were published to different projects or proof of concepts, et cetera, et cetera. So I'm assuming these slides will be posted at some point and available to you. So if you want to walk through these, by all means. Or you can simply email myself, Casimir, or Todd for these. So you can see the list goes on, and there's probably a heck of a lot more I could write up here as well. Now, when we got started with this, one of the initial goals was actually to build the certification testing lab. And we contemplated this very early on. We contemplated this for probably about 6 months to a year. And then we realized that, you know what, we're really not about testing. We're not about taking in a product and saying it does X, Y, Z, yes, let's put our stamp of approval on it. It's more about let's pull together different businesses, all right? Put the different businesses together and let's say, hey, how can we be innovative with the products that are out there, develop new products based upon the knowledge that's out there, and again, give back to that community. So we said, you know what, this model that some places like Indiana are doing, and now New Hampshire University, et cetera, it's really not right for Marist, right? So let's foster that collaboration. Let's build relationships. Let's build these partnerships in the industry. Let's build the industry and the academic community and collaboratively solve problems together. Okay, and let's go ahead and provide instant feedback to that community through the open source initiatives. All right, because we can all collaborate together. Students can jump on this and collaborate. Faculty can collaborate. Industry folks can collaborate. So, let's have an open forum where everybody can participate and not have a closed box where, you're working in a bubble and not see any progress. So keep that development continuously moving throughout that initiative. And so that's where we're really at today. So a couple applications. One of the first applications that we wrote was a program called Avier. And so we started working with the floodlight controller early on. We tested out POX, we tested out some other open source controllers, and we said, you know what, floodlight seems to be the most versatile for us. So we started working with that quite heavily. And with floodlight, we noticed that it's wonderful, but it lacks a graphical interface. And if you're used to programming and you're used to writing Python scripts, it's wonderful. But if you're not used to that and you just want to actually manipulate the network, add, delete, modify flows, maybe pull some statistics about the controller, you know, you have to be pretty versatile in the CLI to be able to do that. So why don't we write a graphical interface to do this, okay? And so we named it Avier, and our thought behind Avier was that we will work with stars, and as the product develops, it will become a brighter and brighter star. Well, the name Avier kind of stuck, so we're kind of stuck with that, I think, at this point. But anyway, the lead developer on this was Jason Paraga, who now works for Big Switch. But what was really interesting about this is he got feedback based upon the communities that he was working with right away that his application that he had written as a sophomore undergraduate student was actually being demoed at the Parade demo at VMware World 2012. For a student, a sophomore no less, having that exposure, that's phenomenal. So that again makes me happy. So this is really the problem that Avier solves and addresses. Would you like to write all this? I know I wouldn't. So again, we went ahead and created this graphical interface where you can do an overview of the switches. You can have more of a detailed switch view. You can have a device view. And then we get into static flows. And really, this is right here. This is your different curl commands that you would have to initiate. And instead of doing that, now you can actually hit this static flow manager down here with a graphical interface to implement that. So it was kind of slick. We also added a firewall to that. Again, we have more or less a before on what you had to do, and now an after picture. And this was really our stepping stone into SDN and into OpenFlow, more or less. So then we said, all right, well, this is great. We built this graphical interface. Can we take this a step further? And what other modules can we create? What else is lacking out there? And so we said, all right, well, there's really not QoS built into, what is the OpenFlow standard, et cetera. However, there's some basic QoS functionality in there. So we created a QoS module to be able to enable QoS, disable QoS, view, create, delete, modify different QoS parameters. And so again, using the REST API, which is more or less the API that is used for OpenFlow development with Floodlight, is we developed this QoS module that sits down here. Okay, and again, a couple other Python modules that set up there for the application. So again, very primitive. As the OpenFlow spec evolved, it allowed for more functionality with QoS. So this was based upon the OpenFlow spec 1.0, which was available at the time, and now we're up into OpenFlow 1.4 and greater at that point, or at this point, I should say. And so OpenFlow 1.3 supported meter tables and some other more advanced QoS processes. If you want to see a nice tutorial that Ryan Wallner did, this is a link for it on that module that was created. Again, basic queuing, but just showing test cases on what could actually be done with SDN and OpenFlow. So then we went on to see, we were using the G82 64 OpenFlow capable switches, and those are IBM branded switches. And so we started doing some testing with Floodlight, and we found that a normal network, if it detects a failure, it would go ahead and pass either frames or packets the opposite way and reconverge properly. Well, what we found was that the network convergence, it was horrible, and we found a bug in the code. So we kicked that back to Floodlight, or I should say Big Switch, and we helped resolve that issue. And so we did some controller failover. Again, this just goes through some more stuff. And then so after creating different modules, creating different applications, so what else can we do with this? And so we went out to the Technology in Paradise, the Joint Techs Conference out in Internet 2. And we were speaking with somebody from Nebraska University. And we were just kind of outside in the hallway, just talking about what we've been doing and what he was thinking about. And he said, you know what? He said, what I would love to see is some type of load balancer. And so we built a load balancer, put it into Avier, and then we got talking a little bit further about host-aware networks and what could evolve from SDN without host-aware networks. And we said, well, wouldn't it be great if you could take a look at a LAN, right? Just your servers on the LAN, and based upon some statistical values that you're polling, do something with them. And whether it be load balance traffic or, in this particular example, provide real-time intelligence to an SDN using different techniques and distributed monitoring, right? So if metric A is greater than or less than B, do C. All right, so let's monitor network usage or disk percent full usage, system load, database table size, and let's go ahead and do something. And whether it's load balance traffic, or say, hey, let's spin up another server and load balance traffic among that, or do something with this, right? So we got into building a host-aware networking module. And again, we were using Ganglia, which is an open source monitoring utility and application. And so we started using Gmod and putting some other server backends and server front ends to monitoring this and making some analysis. Well, then we said, if we can build this on the LAN, wouldn't it be cool if we could take this concept of a host-aware network and go ahead and manipulate it all the way down to the optical layer? Back in 2099, I was actually traveling across the country building out the cogent communications network, right? I was installing all these OC192s in the basements of all these buildings, building out all the DWDM infrastructure. All right, so we're sitting there laying cables, putting in all these chassis. Nowadays, fiber's there. Most of the cards are there. Let's utilize it. So can't we take that infrastructure that's in place and maximize it, make it more efficient, and build it out, orchestrate it, abstract what we're doing at the different layers, and say, hey, let's all do this in software now, okay? So then we took that concept and said, let's add some agility to this infrastructure agility, that now we can have this orchestration from layer 7 all the way up to the application, monitor that application, go all the way down to the optical infrastructure and say, hey, we need more bandwidth. Well, spin up a new wavelength, all right? Or, you know what? We have wavelengths that are over here that aren't being utilized. Let's go ahead and utilize those, all right? And the possibilities here are endless. I'm going to pass this over to Todd Bundy. He's going to talk to you for a couple slides, and then we'll jockey it back and forth a little bit. Yep.
Okay, so this is kind of where ADVA comes into the picture at layer 1, adding that virtualization that we're talking about. So we're talking a little bit about what is it, what is its need, abstraction, orchestration, all of this. And what we've learned is that when we get into the optical domain, we're outside of the data center. SDN, OpenFlow, Open Daylight, Floodlight, whoever you talk to, they're talking about doing SDN in the data center. And those OpenFlow agents were set up to work with switches and set up flows from a port on a switch to another switch within the data center. So what happens when we try to apply this concept of having a switch in a data center talk to another switch in another data center and bring up wavelengths on demand and allow the controller to do that? And about 2 years ago, as part of the Ophelia project, University of Essex, Bristol, we actually built OpenFlow agents on each WDM system, hoping that it would work in the same way that you do with your switches. And what we found out is that the ONF has not really built in support for some of those optical ambiguities that you run into when you're going out over distance. Equalization, dispersion compensation, amplification, all these things were not taken into consideration by the ONF when they built the OpenFlow protocol. So in our next iteration, we decided, well, let's see if we can somehow abstract that complexity of the optical network away from the SDN controller so it doesn't have to deal with it. And so that ADVA could be the first to market with the ability to give you wavelengths on demand through this type of infrastructure that we're talking about at Maris. And what our guys very cleverly did is they built this OF agent in a particular way that would allow us to do that. And of course, our goal is to demonstrate dynamic optical provisioning and demonstrate the automation and orchestration from the application down to the optical transport, just like Casimir was saying. So again, in these real-world use cases, Casper gave the example of Verizon with Sandy. Well, one of the largest banks in the world in New Jersey, 6 more inches, they would have knocked out their millions and millions and millions of VDI desktops. They're doing virtual desktops worldwide, whereby everybody has a dumb device, and everyone has a virtual machine, okay, a virtual desktop back in this New Jersey data center. So there's millions of people around the world in Asia running off this data center, suddenly 6 more inches, and they're out of luck. So what they envisioned is 24 hours before Sandy arriving, is could we just bring up 10 more wavelengths, Verizon, and get these VDIs off our systems and into a system in another data center that's not in the line of fire? And the answer was no. And that's where we went to this particular bank and said, what if we could do this? And they said, well, a team of 12 people at your facility the next day. And of course we did it, and they came, and they were like, oh my gosh, you did it, this is pretty wild. So again, what allowed this is this capability that we're providing here. The applications that we were looking for as being most important weren't necessarily the bandwidth calendaring, because that's really long distance stuff. The real interest in us is cloud bursting. We had some media clients in New York City in 2009. We partnered them up with Level 3. We cloud bursted into an IBM data center downtown because it was going to cost a fortune to build out their data center. All this video content was coming into Viacom, Panasonic, and Sony, and it would cost them $100 million to build their data center. Why not give them 4 10-gig wavelengths into an IBM cloud facility downtown? So that when they had this overflow condition, they could use that facility. Well, that failed. It failed because 70% of the cost was those 4 10-gig wavelengths up all the time. We used all those 4 10-gig wavelengths for about half an hour during the initial cycle of moving these virtual machines or cloud bursting, but the rest of the time, as Casimir said, it was sitting there dormant. Here we are years later, and along comes SDN. And our guys developed this really cool overflow agent that abstracts the complexity. And I'm thinking, wow, can we go back now and revisit this? So that when they bring up those wavelengths, they only use what they need and pay for what they use. And the wavelengths go back into a metropolitan pool for any other user to grab. Now, the next step that these guys will be developing is to virtualize that. Give customers different virtual slices of that entire optical network, where they only can see their slice. It's almost like a storage area network where I create zones. Different departments have different pieces of that storage. Why can't I do that same thing with our optical network? So the one that we want to demonstrate here today is workload balancing. That's really the hot one without it being disruptive. And multi-tenant is very easy because we've got things like SDN-VE from IBM that support multi-tenant. So our goal was, in this case, we have customers that have during the day these type of configurations. They have a ring. They might have 20 10-gig wavelengths between these locations, but unfortunately at night, they need to do this. They'd like to re-provision it to do their backups. Because during the day, everyone's home. So why should I leave all this excess bandwidth out there, not being used? When I can switch it around at night, start doing my backups, finish early, and move it around anywhere I want, and do it from the cell phone if I want. So again, the pieces of the picture are right here. I think that, Roddy, is that right? Sure. Switch out, switch in.
So to build this application to where, LAN, WAN, so to speak, there's multiple pieces, right? So the FSP 3000s, obviously those are the boxes right here that terminate those the WDM infrastructure. The IBM G264 OpenFlow switches that you'll see actually a bigger picture of this, and those fall at at each of these locations. And then there's VM server clusters. We used actually VMware since we were trying to really do a proof of concept on what somebody could implement in their network, right? And we all know that VMware probably holds the most market share out there right now. We are doing some testing with KVM and excuse me, and Hyper-V as well. But for this proof of concept, that's what we used. Different storage. So we did actually use Fiber Channel and iSCSI for the demo purposes. That's all Fiber Channel. And for the OpenFlow controller, we had Floodlight, and we actually tested the IBM controller and the Open Daylight controller as well. So this is the more or less the picture blown up that you saw on the last slide. And so up here at Site A, okay, this is more or less a more redundant site than Sites B or Site C. We have multiple OpenFlow switches. We have the OpenFlow Floodlight controller that sits up in a virtual machine up top. And then we have the Adva OF agent that also sits up in a virtual machine that Todd was just referencing. So you can see there's some dual 10 gig connections down here, and then a single 10 gig connection to each of these OpenFlow switches. So Todd's going to talk about the next slide.
Keep it interesting by bouncing around a little bit.
Absolutely, we're going to keep you awake, right?
That's right. So now we have this entire network. How do we do the orchestration from one controller? Well, obviously it's very easy if we sit there and we take this Open Daylight controller or this Floodlight controller, and we orchestrate it from the SDN controller and AVIOR to set up a flow between these switches in the data center. But the question becomes, what happens when I want to leave that data center up top? Yeah, I can set up flows between those switches any way I want. Well, what happens when I want to set up a flow between that switch up top in data center A and go to data center B? And we already recognize the fact that we have a problem that OpenFlow doesn't really support the optical infrastructure. We ran into that with University of Essex because the ONF doesn't support optical infrastructure. So what we did is our developers developed this Adva OpenFlow agent. And these guys at Maris, very cleverly, Zach and Mary, built this product called Advalanche. And of course, they spent a couple of nights, probably after a few beers, and said, well, let's come up with a name. And they came up with Advalanche. And Advalanche is called upon by AVIOR to set up these wavelengths. Now, if I can't put OpenFlow on every single one of these switches, an OpenFlow agent, how did I do it? Well, what we did is we created this OpenFlow agent that's a waypoint on a virtual machine on your network that simply converts OpenFlow to SNMP. SNMP is what controls our control plane. So now you get all this functionality that you would normally get through our software that you pay for, but now you don't need our software. You go with this Floodlight controller or this Open Daylight controller that's free. You go with the AVIOR software that's free, the Avalanche software that's free. We give you the hypervisor for free. And now you've got all this functionality that we're talking about. So now I go out and I set up the wavelengths, I set up the switches, and what I do is I take the next step. And I'll show you how that sequence works with Robert.
It's like a relay race, right? It has some time back and forth. All right, so automating the flows. So these two applications right up here, AVIOR and Avalanche, that's what we wrote on top of this infrastructure. Okay, so you have these AVIOR and Avalanche. AVIOR is a standalone application that can actually call Avalanche, or you can simply open up Avalanche by itself as well. And so if you open up AVIOR, that's your network management application, you make a call out to Avalanche and say, I want to manipulate the network. We go down to the OpenFlow controller, and we say, yes, we need to spin up a wavelength. Okay, so if we need to spin up a wavelength, we'll go down to the OpenFlow switches for the actual flow, but we'll go through that OpenFlow agent to talk SNMP down to the Adva FSP 3000s. I'm going to pass this over to Zachary Meath right now. He's going to talk about the new and improved AVIOR, which you'll see is quite different than the AVIOR that I actually just showed you.
So after starting this project, we decided to kind of do a rewrite for our old AVIOR. The old AVIOR was written in Java, and you need to download it based on your operating system and such. And it was a very fat client, so we decided to create a web application so it could pull data directly from the controller, and you can manage your network from your smartphone, tablet, whatever you want, anything that has internet access. So I guess I'll go into the video. Right up top. So here is a topology view of AVIOR. Right here we can see just the switches on our current network. These four right out here are the IBM G264s, and the center one is the Adva OpenFlow agent, which represents those three optical nodes, or the WAN.
And this is what you see on a cell phone, right?
Yeah, so this this is our new AVIOR application. Here are just some stats that AVIOR pulls off the controller about your switches, so you can view all kind of stats and what flows you have on each switch. And soon it'll show you can also look at information about your hosts, and you can see your overall topology. Here's the static flow manager, so a network administrator can go in and automatically provision a flow based on whatever they need. And there's a topology of the entire network, all the hosts that are on each switch, and you can see TPIDs, and you can zoom into each switch if you need to inspect it further. There's the WAN represented in the center there.
Thanks, Ed. So this is more or less the workflow. So if you were Bart Simpson up here, and you have your iPhone, your tablet, or whatever, you pull up Avier and start working with Avier, you can make a call out to Avalanche. Okay, and you saw that new graphical interface was actually meant for a smartphone or a tablet. It's a lot tighter than the old application. It's web-based, etc. So either if you're Bart up here, or if by chance you're an automated tool like Ganglia, Ganglia is sitting in the background monitoring these applications, okay? And it's monitoring the different servers for CPU, the CPU percentage, okay? How high does that CPU spike? And our threshold was actually 75%. So if the CPU spiked to 75%, do something, okay? And that do something was to spin up a new wavelength down to the optical layer, all right? Increase the bandwidth. Take that VM that was spiked and migrate it to a storage vMotion and a vMotion from one data center, migrate it to the other data center, but only after that additional wavelength was spun up. Okay, so take advantage of that additional wavelength, migrate it. Once you're done, tear down that wavelength that you just spun up, and put the ring back or put the topology back into the nature that it was prior to doing this migration. Okay. So either a user or automated tool decides to modify the network. There's a call out to Avalanche, either through Avier or directly. We can, either the user or an automated trigger can modify that transport network through Avalanche. So we're down at the OpenFlow controller at this point. And let's go ahead and provision a Lambda. So we hop down, go through the OpenFlow agent, talk OpenFlow to SNMP, modify the FSP 3000s, spin up that new wavelength, and complete whatever application aware action that it deemed necessary. Okay, so we go all the way back up to the top here, or back to the application, I should say. So the next part of this is Avalanche. So I'd like to introduce Mary Miller, who's an undergraduate computer science student.
So Avalanche was created to complete all these different tasks that you've been hearing all about. We wanted this graphical interface to be able to provision the WAN network. This also would be able and accessible from your tablet, your iPhone, anything you want. Normally when we do this demo, it's from an iPad we're holding as we walk around the room. This is a very easy to use type of application as well. It can be, if you have an iPhone, iPad, you can easily draw and delete flows or whatever you want that way. And it's all one click, so it's very easy to do. This is from a desktop computer view of Avalanche application. This shows the current topology. Obviously nothing was provisioned when we took this screenshot. You can always get the current network, or with just drawing it on, you can provision the network. You just draw the links and hit provision network, and off you go. Then that happens within 30 seconds of provisioning and hitting the provision network. You can see them flashing green and then solid green to see the change. We have a few features on the Avalanche product. It would be the different profiles. So a great thing would be to automate this whole process. The first thing you can do is you need to save the different topologies in order to automate it. So we can save them. We call them profiles. We have, different profiles, you could have double A to B, double B to C, just showing the different links between each of the different sites. We also can schedule these events by choosing, first we can create our own custom profile. So, if you wanted to add one that wasn't already there, you could always easily do that. We can also schedule these profiles by choosing a profile, time and date, and then if you want that repeated. So if that's weekly, monthly, whatever you want. So if you wanted to back up your data center at 2 in the morning and you really didn't want to get out for it, you wouldn't have to with this type of application. I'll pass you off to Zach for the triggers.
So in another step to automate what we're doing with Avalanche, we developed something called triggers. We have Avalanche constantly monitor the network and the hosts on the network, looking for anything you want to define. When you define a trigger, you say, for example, I want to look at CPU utilization. If the CPU utilization goes above 75%, I want to migrate the VM over to another data center. And while it's doing that, Avalanche is also aware of the network and the bandwidth to go from data center A to, say, data center B. And it can bring up another wavelength to migrate that VM, and then it can bring it back down again once that migration is over. So triggers can be really customized to anything a network administrator would want to automate. Here's the interface for creating triggers in Avalanche. We'll show you a demo right now, a video demo.
Hey Zach, real quick before you hit go on the demo, now that you've got this sort of base set, right, and there's a couple folks in here, so I'm going to kind of ask a leading question, but so you've got this set up. To make these modifications or changes, I mean, it seems like it would be very simple to go into a customer and say, hey, you've got 2 data centers, you want to do this backup at 2 a.m. in the morning. I mean, what does it take to then provision this for a real customer at this point? Is it something that simple that's a couple days worth of programming to modify it to that one customer, or?
It's a good question. So we built this as a proof of concept, first of all.
Yep.
To see if this could be even done. Could this be accomplished? And so we proved that it could be accomplished. And so let's take this to the next step. And the next step would be, first of all, let's either productize it, and that's in Adam's ballpark.
Yep.
Or let's advance it. What else needs to be in this to make it a product, or to see what customers want to be able to make this more effective. And so we have another kind of iteration of this work that's more or less future work to bring it into data centers and say, all right, well, if there's multiple tenants within this data center, how can we bring this concept of multiple wavelengths, possibly in a pool that are dynamic in nature, that we could spin up based upon individual clients that might need them at any point in time, okay? And so it comes down to, all right, well, does the customer own the optical network? If they do, then by all means, they could do something like this. They could spin it up. The amount of implementation time, it depends on the complexity of the network, right? How many transponder cards do they have? How many lambdas do they have? How many ports do they have? How many data centers, et cetera? So that would need to be taken into consideration. Then it's, all right, well, are we basing which lambda is utilized based upon utilization of that lambda, or are we doing something additional to that? And so if we continue down and we just kind of put that aside and we say, all right, well, let's get back to this tenant network, and we say, all right, well, if we have one data center with multiple tenants and a service provider owns that network, right? All right, service provider owns that network. Well, they want their own software-defined controller on there. They want their own OpenFlow controller. They want to run their own network, and they're very lenient, or I should say, very leery about giving control to the client. Right? I know if I was running that service provider network, I don't want to give my controller to my client, or my customers. But I might want to give a small little granular piece to that customer. So the next iteration of this work would be to take that software-defined controller that service provider owns and say, hey, customer A or tenant A, guess what? I'm going to spin up a virtual controller for you. You can access this virtual controller, and you have X amount of bandwidth available to you over my backbone to data center A, B, C, D, whatever it is. Okay? And maybe it's even based upon exactly where that customer or where that tenant resides within the other data centers that I connect to. Data center B, same thing. You have your own virtual slice, so to speak. And virtual slice is used for different terminology, but in this case, it would be literally, hey, we have a 10 gig connection from data center A to B, and we have 10 different tenants, and each tenant is given 1 gig of traffic over to the other data center. How you carve up that 1 gig of traffic, that's your bet, right? And so if you want to provision that as 10, 100 megabit, slices, so to speak, you do that on your own, tenantized SDN controller. All right, so that one, your own virtual controller. And so that's some of the iteration of this next iteration that we're working on right now.
And one of the other ones is, there's also tactical solutions. Right? What we're specializing in here, when we talk about SDN with ADVA, is we're talking about data center. Other people, if you go to Verizon or AT&T, they're talking about, let me do this nationwide SDN thing and slice up bandwidth all over the place through OTN. We don't, in the data center, you don't want to do that. What you want is you want to have a bunch of wavelengths. You might want it for FICON, InfiniBand, 16 gig fiber channel, 10 gig Ethernet, 100 gig Ethernet. And you want to be able to have that on demand. And you don't want to go through an OTN with all that traffic. You just want to get this passive wavelength and bring it up and have it go to the fiber channel switch, or the FICON switch, or the InfiniBand switch, or the Ethernet switch. And so we believe that our solution is, correlated directly to data center connectivity as being a natural application for this, especially in the metropolitan area. The second application is today when we sell a network to a customer and they want optical layer protection. Okay, I've got a $10,000 card here running 10 gig, whatever the cost is, now I got to put another one here. My traffic comes across the cable, it gets split. It goes east and west on my ring. My receiver's on here, my receiver's off here. My cost is now $10,000, $20,000, $30,000, $40,000 for one 10 gig connection, just so I can have protection. Now, what happens when I just have one 10 gig connection and I have a pool of wavelengths out here? I'm not buying a second card. I'm literally switching in to any one of these links that might fail through control plane, a backup link from the pool. So now my cost has dropped dramatically. It's not one-for-one provisioning. It's 1 plus n. I could have 10 gig links backed up by 2 that sit there. If any 2 fail, I'll pull in these 2 from the pool, and I'll put them across the 10. And then we have the load balancing application that you're talking about. What happens when I hit 8% on a link? Well, I want my SDN controller to go and order up another one. That's a tactical SDN solution that customers could buy today. It's just a package in the optical-only arena. But what we're doing here is we want to go beyond just the optical arena, and we want to move up the chain and have an application aware. I think that's the big difference here, is that layer 1 through 7 orchestration that ADVA can't bring to the table. But what we can do is make sure that if you buy our product and you get to take all this free software, we'll give you free programmability, free agility, so to speak, once you have it in place. So, unless Casimir, you have anything
I
else?
think that's fine, Todd. Very good.
Okay, so here's our demo. Up here in the top right, we have video streaming off of a virtual machine on our network. In the bottom right, we have Anglia, which is an open source network monitoring tool that Avalanche reads from to monitor the hosts on the network. And it's monitoring the CPU usage, the use case I was talking about earlier. In the bottom left, we have vCenter, so we can see when the virtual machine migrates. And in the top left, we have Avalanche, so you can see the connections inside the LAN. So we spiked the CPU utilization on the virtual machine, and in maybe 30 seconds or so, Avalanche will pick that up, and up there you can see that it brought down the 2 other wavelengths from A to C and B to C, and it's going to use those links from A to B. So it's good, and then it's going to bring up another green link. Once that extra bandwidth is in place, it's going to migrate the virtual machine from data center A, where it is right now, to data center B. So in a minute or so, you can see that on vCenter.
see it down there. It should be showing, there it goes, 15%, 20%.
Yeah, there you go. So there, the virtual machine's migrating, and then once that virtual machine is done migrating, it no longer needs that extra bandwidth between A to B. So it'll take that link back down and then spin up the links back to where they were, all while not disrupting the end user's experience of the video on the top right.
So again, this is like your VDI example. The Sandy's coming in, got millions of users are about to get knocked out. What's the productivity loss to that bank? And all of a sudden, this kicks in automatically, brings up the wavelength, start migrating those virtual desktops into out of region, and doing it completely automated. Okay, this bank said that takes them 2 months to do. So again, this is a great thing. Now it's getting the network back.
And just think about the Super Bowl, right? I don't want to miss a heartbeat of that game, that awesome catch in the end zone where, 10 seconds left in the game. And, that can count for that.
So one of the other things here that you probably notice is that we use VMware, vSphere, vMotion, vStorage. It's very expensive. We don't want to use it. Okay, there are other people like OneNet, Learn, maybe even KINBER, that is already doing work with OpenStack. Okay, we would like to get rid of VMware in this picture. We'd like to put in OpenStack to do the vMotion, vStorage migration. Because now we have an entire solution that's free that covers the full gamut and covers everything within the data centers. So if that's what we'd like KINBER to do, we'd get a test bed going with KINBER, a test bed going with OneNet, a test bed going with Merit. We collaborate all you into a consortium. We provide you huge discounts on the hardware, and you do this co-development, and you share what you're doing with each other. So that Merit may be ahead in one area, and maybe you guys would be ahead in another. You collaborate. We collaborate with some other universities, and now we've got a really, really great way, number one, to get students engaged. And as you can see, they're very engaged, and we'd like to have more of that. At Marist, we have a training curriculum. We bring students in there, they get trained. That it could be anybody within the KINBER network doing the same thing. Any university that wanted to go through this and get trained on what these guys got trained on, we could set that up. So with that,
Yeah, so obviously there's different pieces to this puzzle. We kind of walked through the majority of this before, but you'll see a recurring theme in here: open source, open source, open source, with the exception of VMware, right? And again, we're working more and more with KVM to more or less keep with that open source initiative. So as Todd just mentioned, collaboration. I would love to see a working group come out of this, where we have multiple universities, multiple research network folks get together, form that working group along with faculty and students in the industry, and partner together and define what needs to be, what's coming down the pipe. What can you utilize in your networks? What can, what's great for us? One thing that Marist, where Marist really differentiates themselves is that I am, as I mentioned before, that I did the installation for Cogent Communications. I have an industry background, and I moved into academia. I am still very closely tied to industry, but I also have a research agenda now as well. So I am not a strict research scientist where I'm sitting in a lab looking to poke holes in things and just for strict research. I am looking for research that can actually foster collaboration and give back to the community and do something. Anything that we do in our research network, we actually take and put in our production network at Marist. And so that's what I'm truly about personally, and hopefully the students take that along with them as well. Mary and Zach, they've been with me for a year now. I'm very sorry to see them leave this summer, but they'll be back in the fall. And but it's as you can see, they can hop up, they can present well. Obviously, they can code well. So we're doing something right at Marist. Thank you.
questions?
3 email addresses. So if by chance you need to reach out to us, please do. And I can't get away from this slide. One of my students put this in one of my presentations, and for one of the conferences that we did, surprised the heck out of me when I turned the page to the next slide. And I got the same response from that one, and I can't pull it out of my slideshows ever since. So yes, please, questions.
Do you guys use Genie at all? Do you, or do you have Genie Rack, or you?
We do not, all right. I have spoken to the Genie, or not to the Genie folks, but I've spoken to, say, NiserNet, who actually started using some Genie stuff at NYU. I've spoken to other people that have used Genie. The reason why I personally did not go the Genie route in the beginning was I like to pick and choose what hardware is actually in my rack. And when I first started this venture, I wanted to be able to pick and choose what servers, what switches, et cetera, et cetera. And at that point, back in 2011, it was a standard rack. It was pretty much HP switches, here you go. So nowadays, it's changed, and it's a little bit more flexible. It's actually a lot more flexible than when I first started. So if you're thinking about a pilot, it is a really good way to go. It's a good foothold in the door where you can literally, hey, I have this rack of gear, I can roll in and start some testing and pilot testing. So it is a good way. I just didn't, see a need at that point for my group.
Was there a Genie pod near you? Or did you have access to a gigapod nearby? Or?
Down in New York City, I think, is the closest Genie pod. And I think that we would terminate down at NYU.
That's true, Rob. And I'll also throw in that we're collaborating with some folks at the City University of New York, CUNY, down at City Tech in Brooklyn. They have some Genie accounts. They're doing some development work to train their students using it as an educational vehicle rather than a research one. But we do have that linkage as well. So if we decided to go that way in the future, we have some people in our little consortium that are trained on Genie.
And they're also trained on the FSP 2000 because CUNY, where your wife works, has got their own test
As
bed.
it happens, yes.
Shocking.
Go
So,
figure.
Robert, you mentioned SNMP at one point.
Yes.
I don't remember what slide it was, but
So the ADVA OpenFlow agent, okay? There is, when we wrote this, we were dealing with OpenFlow 1.0. The 1.3 spec was kind of on the horizon, but it wasn't, it wasn't ratified yet. And so the only way to talk down to an optical device was to go through a translator. All right, so we had to go back and say, all right, well, what does the ADVA FSPs, what do they talk? What do they speak? Right? What language? And they take their commands via SNMP. So take that SNMP string and how do we get it up to OpenFlow? Well, throw a translator in the middle. Let's speak OpenFlow up to the switches, OpenFlow up to the controller, and talk SNMP down to the FSPs. All right. So that's where SNMP comes into play in this scenario. And we're actually doing some SNMP traps to monitor some of the network devices as well.
And the other thing too, of course, is that if I put OpenFlow in every one of these boxes, which we discovered the first time around doesn't work, let's say that in the future they get it to work. All right, we can always get rid of that waypoint and go direct OpenFlow. The minute I go direct OpenFlow to every box, I'm not extracting the network anymore. So am I still able to create these virtual slices that we've been talking about without having the abstraction would be the question.
So it's a different philosophy, right? It's a different example. It's a different implementation at that point. So yes, you could, because that's the nature of the OpenFlow spec. It's the nature of an SDN. It's just how you would actually go about it. So I think all the work that we're doing with ADVA, whether it traverses down this way or completely takes a different path, I think it's going to evolve in the future, and it could potentially evolve right down to having an OpenFlow agent, right, an OpenFlow agent right on the optical box. Or you're always going to have these legacy devices that, frankly, if I'm a network administrator or in either a research network or a network, I'm always going to have some legacy network devices that I'm possibly not going to get rid of because either of cost or they're playing some key role that I just can't get around. And so how can I talk OpenFlow down to them, right? And it's got to be through a translator. So I don't see this as just an ADVA, approach or an ADVA problem that is solved here. I actually see this as an industry standard that, hey, if it doesn't speak OpenFlow and you want an entire SDN, to manage these other devices as well, throw a translator in and translate to whatever they can talk, whatever language they can speak. Absolutely. So, yeah.
Are you in the terms of dynamic provisioning of wavelength and network path, are you tracking power consumption in terms of, because I can see opportunity here for power savings.
Yep.
If I could turn a couple of lasers off from like 11 p.m. to 4 a.m. or 5 a.m., or turn them back on as soon as traffic hits a certain trigger point.
So,
Do you track consumption at all in the data center of wattage or so?
we currently do not for the work that we've done. At some of the work that Columbia University is doing, more or less in the optics, we've spoken to them about this, and it is a consideration on either a future release of this, or I should say the future of this direction. And so, you know, you might have this pool of wavelengths, but you also might have this huge static network that you already have defined, and that's your current and traditional traffic, right? Well, during the night, if you don't need that traffic, spin them down. So we have thought about that, we just haven't done anything with it at this point.
Something for future set of grad students.
Yeah, exactly. We gotta say something, right? Yes.
Yeah, along those lines, I mean, like something that's kind of making my head hurt right now is how do you calculate cost? Because like at layer 2 and layer 3, we're all familiar with protocols where you get like this is the most efficient route. But if we're going all the way to 7 and you can control the way down to 1, how do you set up the algorithm like, oh, we're going to be a lot more efficient if we move to the same hypervisor and save this, or we're going to be more efficient if we're in 2 physical locations but are using more waves? Like that to me is absurd.
Sure, so you don't have to take it in that big a chunk, right? You can still utilize those lower layer algorithms to base, you know, what is the preferred cost, what is the preferred path. So you don't necessarily have to say, yeah, we're orchestrating 1 to 7 all the way up. You know what? In the middle there, you're still choosing the best path, whether it be, you know, BGP, or whether it be, you know, over MPLS network, or, you know, simply OSPF, or whatever it is, you know, say on layer 3. You still have an algorithm down there that's determining that path. Could you deviate from that with OpenFlow? Absolutely. You can say, hey, I don't care about what path that OSPF is giving me. I want to go this way, and I'm going to, you know, throw up that match action table, and I don't care what it is, I'm going this way. So you can deviate from that, but why would you want to? If your lower layer algorithms are providing that necessary information, use them. You know, at least that's my philosophy. And there's other researchers out there that will, you know, we can have this debate all day long.
But that's the whole idea here. We get these test beds going, KINBER next, Merit next, and we start collaborating with this. This is the kind of discussions we need to have. What about this? What about that? Well, we've tried it this way and we ran into that. Oh, I didn't know that. And we get that whole thing bouncing off each other, and we learn a lot. And we move faster to our goal.
So Todd, remember the example that I showed of how we took a client who had 10% utilization, we analyzed the workload, there were lots and lots of variables that affected their workload. There was about a dozen that really made a difference, and of those there was maybe half a dozen that really moved the needle 80% of the way. So we didn't have to model the whole thing in order to see some short-term gains. There was low-hanging fruit. I think there's similar use cases in the WAN and in the MAN. So we give the example of moving virtual machines across a network. So the time it takes to migrate a virtual machine depends on what? The size of the VM, the bandwidth that you put out on the network, the dirty page rate of your application. There's 3 or 4 variables that affect VM migration. That's all you need to generate a cost function. And one of the strengths of SDN is that you can get some of those variables off the server, whereas today's switches are restricted entirely to the stack that's on that little box. They don't know anything about page dirty rates. The switch itself has no idea how to optimize VM migrations. We can do that in an SDN environment. We can pull key statistics from anywhere. So part of the next phase of research, as you said, is getting use cases like that into the test bed, or in other places, doing that same kind of analysis, and finding that low-hanging fruit, a handful of variables that we can easily model and go from there.
And what Casimir had mentioned is another collaboration with CUNY based upon more research and more development that we've been doing as well. So this is more or less fostering that collaboration and those partnerships.
What's a page 30 rate?
Oh boy, how much time have we got left? So If you want to move a virtual machine from one place to another, using VMware or OpenStack or anything else, you've got a hunk of memory on one side.
It's like a paging within memory.
Exactly.
Okay.
You're talking paging inside memory, right?
Web page.
As-
Page.
I'm
No,
saying-
think about a VM migration where
I'm
it's,
thinking
you know,
paging inside memory.
Okay.
yeah.
Yeah, sorry about that.
So, another question.
You're not allowed any more questions.
How many more tickets? I'm a customer now.
Double dipping.
I'm a member, I'm a paying member. What, in your demo there, what was handling your layer 2?
What was it? Where?
What, yeah, in the demo we saw that you were showing up there. Where's
On the-
layer 2 being handled?
On the LAN or the WAN?
Well, and both.
So you've got the OpenFlow switches that are handling layer 2 on the LAN, okay? And then you've got the SDN controller that's managing the layer 2 on the LAN, but it's also handling layer 2 on the WAN. So it's taking those Ethernet ports off of the ADVA FSP3000s. And what Zach showed you was, you know, that one little circle in the middle there. That was really that ring. It was those 3 ADVA FSP3000s represented as one OpenFlow capable switch up to the OpenFlow controller. So really,
So you won't run a spanning tree though?
no,
What-
absolutely not.
We look just like all those IBM switches, but when you go from a port on our virtual switch to another port, you're really going over the wide area. So that abstraction allows us to make it look like it's just another IBM switch, and when I want to go to the wide area, I go to that port, and that port if I want to go from A to B. I want to go from that port to that port if I want to go from A to C. And that's how it's provisioned to that abstraction.
I haven't tried to take your question one step further. I have not tried to take 10 traditional Ethernet switches, throw them behind an OpenFlow switch, run spanning tree on those traditional switches, and not spanning tree on the OpenFlow switches. But you have my wheels turning now, so.
Don't most OpenFlow controllers, you know, not just IBMs, but don't they do a lot of translation anyways? Like if they want to talk to a layer 2 or 3 router switch, they'll convert BGP, you know, OpenFlow to BGP, get the data set and bring it back into the controller?
It depends. So yes, you can do some of that, but inherently, right out of the box, no. So there has to be some programming there. Can you just pop it up in your network and, you know?
Oh, I know none of this is possible. I know it's not just fingers.
Right.
I know that.
So Brian, you're kind of being a shill with that question. I mean, part of where this is trying to go is we're talking about setting up the Sandbox and the Kimber network. What are some of the use cases of what you'd want to do in terms of provisioning the switches, the routers, the optical network that get to be services that are valued to you, the member, and the other members? And, you know,
So before you take that any further, another question, what other type of business triggers have you either programmed or envisioned programming? I saw that one slide where you were talking about budget calendar work, I guess. I mean,
Yeah, so
what other triggers are you envisioning that people like us would be interested in exploiting, using in an SDN cable network?
that's a really good question. So I'm going to answer your question indirectly, okay? So one of the initiatives that we have going on at Marist is an open academic education environment utilizing research networks. And so in this OAE environment is to share and collaborate with other professors at other universities and potentially collaborate and teach either jointly or disjointly, or possibly use somebody else's course materials to teach a course, but not necessarily have it all tied to Marist's infrastructure, right? So in this OAE environment, say, you know, we're connected down to Georgia Tech, right? So we connect down to Georgia Tech, we're pulling off of their OAE instance through an SDN to be able to co-teach this one class set. All right. So if we teach that one class, we're utilizing materials here, and we're utilizing, you know, different disparate materials all over the place. Now, that doesn't have to be static materials, that can be dynamic materials, that can be live video conference feeds, that can be, a multitude of different things. But to spin something like that up over one cloud initiative that a student can go and register for at one place and utilize an entire educational network to educate that student population that's coming in here and accessing resources from all different universities, that's pretty powerful. And if you think about it, that's kind of the way the internet started, right? We haven't gotten back to that point, but I see this is a direction and heading in that direction, or heading that initiative. So different specific use cases like cloud bursting or tenant-based applications. I'll be honest with you, I'm honestly looking for this group to provide that to me. And so, I could sit here and say, hey, I think you should be doing X, Y, and Z, but you know what? Your customers are actually coming back to you and saying, hey, I need X, Y, and Z. And you're sitting there saying, I don't know, can I do that or not? I would love to hear about those and say, hey, well, I don't know, but hey, Mary and Zach, hey, go program this for me. Or better yet, the best part about SDNs is these two right here. They don't share what the majority of us have in this room, and we have baggage. They don't, right? We have this vast amount of knowledge behind us for the past 20 years that we say, you can't do that in a traditional network.
Don't worry, they'll get just as jaded as us. Being in this industry, don't worry.
That's why they're
That's why we move them in every year or two, right? That's why we cycle.
Move them in, move them out.
And hanging with the admin dudes, you gotta be careful. You know that.
So, but seriously, they don't, they'll come up with these out-of-box ideas that you're like, it can't be done. And, 24 hours later, they say, I said, well, here's my laptop, I just programmed this over here at SDN.
I mean, as an example, we originally had a show around the US and Canada that you guys were showing, a virtual machine migration, not this. But they're going up there in front of an audience of 90, 100 people, and they're saying, look, see it migrated. You see these lines going across. And I said to these guys literally 2 months before our symposium last year, I said, guys, I can't have you go up in front of 200 people in Times Square and not show something live. And they said, well, we think we could fire up a video and we can do the migration while this thing's all happening underneath it. I was like, is that even possible? Now, the people at EMC and Akamai does this on their back end in their server racks. But they need to move those video streams between data centers. They say, no, you can't. We'll get a disruption in the video. I don't know how they did it. They just did it. And yet I go to these other people at EMC and Akamai and they say, no, you can't do that. Or JP Chase, or Morgan Stanley, or Goldman Sachs. And suddenly they're coming up and going, how did they do that? And for them, they pay a fortune because they've got people in the optical group, the LAN group, the applications group, the firewall group. What happens when I can slice through all that? The savings have got to be huge. And now I automate it. So yeah, we've proven how you can do it, but there's huge politics in eliminating those silos. And so this is a delicate situation when we show this, but it clearly is the future because we know that those layers have got to be automated.
I'll make one final comment on that, John, really quick. One of the issues that always comes up with those kind of questions is this is such a fundamental technology. It's like if you came to me back in the 1960s and you said, I've invented this great new thing called virtualization, and I can make virtual machines. And you said, what's a virtual machine good for? Well, it's good for hundreds of thousands of things. Or I've invented this great new thing, and it's called a laser. That's a nice thing. What is it good for? Well, it's good for welding cars together. It's good for dentistry. It's good for brain surgery. It's good for satellite communications. On and on and on. What we've got here is a very foundational technology. So we can time slice the network and do bandwidth calendaring like Google is doing with it. We can carve it up into virtual tenants for a cloud infrastructure. We can put video over it without being interrupted. I'm sure that we could do voice over IP over it, a lot of channels at once, and keep all of those things isolated. Rob told you about how we're sharing virtual classroom materials live when they're being updated dynamically. there's so many possible use cases and sets of variables that one can optimize on. That's why we're saying we need your help defining use cases that are meaningful to KINBER. We'll go back and work with you on how we're going to implement those and spin them up.
So Mike, just a quick question. As I see kind of the audience here, right, I know there's more folks that make up KINBER that weren't here. I guess I'd like to offer up or suggest that we maybe do a shorter follow-up on a group call with the rest of the KINBER members, because I mean, yeah, but I guess before we do that, you know, you guys tell us, was this worthwhile? Does this does this hit a mark? Does this hit something that you'd want to see shared amongst the rest of the members? Because I know we don't have everybody in here.
And if you say yes, you get KINBER team.
I've got 3 tickets.
Yeah,
Oh.
yeah.
Okay, I mean, if it doesn't, if we like walk out here and this is cool, but this just doesn't hit a mark, well then, let's know that now, but I think it does hit a mark, but I don't, I'm in the industry, I'm jaded, so I already know, I think it hits a mark.
See, and I think there's multiple marks. I mean, if you get these students trained on this now, and you get a curriculum going here within KINBER, it's a no-brainer. They're gonna sit there and charge ahead. It's gonna create great reputations for you guys, just like it did for Marist. And the whole idea here is really to help the students, right? I mean, granted, we have a network, that's great. But how do the students take advantage of it? How do they learn about it? How do they work with it? You know, that will get them jobs when they get out. And after paying all that money for my kids to go through school, I know what it's like to have them all come back and live with me. And granted, they've all got jobs now, but it took a while. So, you know, that's the key.
I'm not clear on the curriculum.
What
do you envision?
Let's talk about how KINBER can utilize this, because our vendors are willing to give us the equipment to replicate what Marist has done. And I think there's a couple different uses where, from KINBER's pen rent standpoint, I have a lot of ideas based on what we can do with this technology to make the network better. I think there's also the aspect of giving universities at the faculty and student level access to this, so they can continue down the track that Marist faculty and staff are doing. And like you said, the first step is really to get this working group started, to get some concrete ideas on how we want to do this, hopefully do some parallel tracks that, you know, it's IT staff that are interested, it's faculty staff that are interested, and it's KINBER participating as well, and throwing out some ideas as far as what we can do with it. I mean, I heard things like, you know, we're trying to move to our service is, the service is the port, and you do whatever you want with it. So if our service is virtualize your port on the fly for things that you want, you know, you need a 200 meg pipe to some other member for 2 hours, then you spin that up on your own. I mean, there's a lot we can do with what I heard. There's, you know, disaster recovery positioning. We're building pipes to disaster recovery companies like DLT, DSS, Xand. And if we have one large pipe there that can be spun up on the fly with this kind of technology, that kind of gets out of the idea of we have 10 customers that each want a gig to this disaster recovery site. Let's use this technology to maximize that link. There's a lot.
And then use the scheduler to schedule, each school gets a...
Bandwidth scheduling, yeah. You know, Pennsylvania, the broadcasting stations, you know, maybe the service is not 200 meg connections to all the TV stations that's up all the time. Maybe it's, you know, I know when I'm going to stream this show to these other 8 broadcasting stations, I'm going to use this to schedule how long I need that bandwidth and then turn it down afterwards. So there's a lot from the network perspective that I would like to do with it, and I would like to be involved. So I think the next step is, who wants to participate in the working group? Marist has said that they will continue to work with us on this. And I do think there are people here that could not be here today that are very interested. Some folks from Bucknell said they would love to talk to the comp sci folks and involve the faculty and students in something like for this?
I think Penn already has an SDN test bed going on, right? I think you mentioned earlier that it'd be nice to collaborate with industry.
Yeah, we'd like to be on the working
Okay.
WHYY in Philadelphia.
Did you guys talk about the Win Lab?
No,
Okay.
no.
So we might be able to tie that into this as well.
We're working, we're becoming partners of a regional test bed with a Rutgers initiative group called WinLab. And they're at the point where they're taking SDN technology and OpenFlow, and now they've demonstrated the national model. Now they're moving it to the end users and the real world. And the same question is being raised by them, but tell us what you want to do. I mean, that's basically, just as you guys were saying, what applications do you see? And give us your wish list, not just, don't be restricted. And through that NSF-funded project, we're going to interconnect probably WQED in Pittsburgh using KINBER. And that'll be a test bed running on KINBER, a small piece of it, to start to develop some of this.
So we're providing the transport to Rutgers, WHYY, and WQED, and each institution will have SDN switches and codec unit on site. So really, I mean, the initial conversation was really just, we're providing the bandwidth and the transport between the locations, but then that's the idea of, today, what is that? That's us spinning up a certain amount of bandwidth that's up all the time.
See, the application though is that remote transcoding on that Zippy cluster. That's it at Rutgers. That's the app.
Yeah.
And the secret sauce of the OpenFlow piece is the signaling that happens between the NEC, the controller and the NEC switches.
Right. And that, of course, is bursting large amount of bandwidth at certain times.
On demand.
On demand or scheduled for, high definition, super high definition video content.
Yeah, there's no dynamic aspect to it though, other than there's no signaling and dynamic creation of circuits. I mean, KINBER's going to build and provision a VPLS service at a prescribed bandwidth, and then you'll have that bandwidth be available to the application across Penman. It'll be a static setup.
Right, for this test, for this.
For the QED.
Right, for that test bed.
HYY, Rutgers test bed. Yeah.
But there's lessons to be learned through all that.
Oh, yeah.
That are applicable to the future development, as Mike was suggesting.
What's the transport to Rutgers?
Of Penman itself.
What's the transport to Rutgers, I2?
No, it's standard networking technique, it's not I2, because it's local. The hub in Philadelphia is at 401 North Broad Street, you may have heard that, right? Rutgers is already connected and WinLab is connected to the same location. They have their own connection that's actually independent from Rutgers. So, and that's where they've been doing the national test. So we are connected to 401, and our KINBER point is at 401. So it's a local network, you might say, or binary network in that region.
Don, do you guys have a comp sci department, faculty that might be interested in participating in this?
Possibly.
Okay.
I mean, I was thinking more on the, disaster recovery.
Okay.
Cloud, like, even moving to the cloud with like backup. I mean, bandwidth is the #1 constraint. If we can, even if we're, working with other colleges, having just, to be able to suck up all the bandwidth when we need to do a restore on demand would be awesome. I mean, right now that's the biggest constraint for us is, sure, we can get it in the cloud, but we can't get it out in a really quick time frame. So I'd be interested in looking at solutions like this.
So one of the examples in Germany is Deutsche Telekom wants to create kind of like, it's kind of like a where they provide wavelengths on the band on the back end. The user comes into the front end, right, of their service. And from there, they can pick from 5 different cloud providers on the back end. Now today, they hammer up wavelengths to this cloud provider. They want 5, 10 gig wavelengths to do what you said. They've got a backup they got to do. But that provider really made them angry because they had a power outage or whatever reason. So now all of a sudden they say, fine, tomorrow we switch to another cloud provider. And if you're not happy with that guy, you switch to another one. You switch to another one. Rather than fixing everything in to their cloud provider, you're locked in. They want to provide a service, the same way that you would sell gas or futures or stock. I mean, literally, or gas, anything, where it's on demand and to any provider you want. So one of the places that they want to take the Mayor's test bed and actually put it into a test environment for even production is that back-end type service offering. Because they envision a world of the future like Amazon 2 weeks ago. They dropped their prices by 40%. Well, guess how hard it is to connect into Amazon? It's not hard. You just sign up and go. And why would you want to be locked into a service provider? It's hard enough being locked into your own data center. It's not competitive anymore. So wouldn't it be great to have this ability to switch in different cloud providers on demand based on, hey, they've got a special running this week. I can save X amount of money just by switching my wavelength over here and running on that special at Amazon for the next 2 days. Now I know right over here, you create this competitive environment. You're just switching between them. And that's what people are starting to think about. But again, no one's demonstrated this until now at layer 1. And so that's an application where they think it could be applicability. One of many. But it's all being explored. And to prove it first, show it. Now people are thinking, geez, it can work. Now where can I apply it?
And there is, for those of you that are not familiar with this, there is a working group for optical. There's an optical transport working group for the ONF now for the OpenFlow spec. Some of that's out in OpenFlow 1.4.1, but they haven't touched the iceberg.
So what do you envision? You said you'd like to start a working group. Mike has said KINBER would like to start a working group. You said you'd like to start a working group. So I see 5 different working groups that could spin out of this, and we need to spin out of this because one group would just get too unwieldy. And at some point, you're going to start seeing people drop off because that group is focusing on something that is not of your particular interest. So what, from a research standpoint, and I'm at a research school, what do you want to get out of this effort? And from your request of a working group, what do you want to get?
So I'll be honest with you. I would like to form more or less a collaboration and partnership with the research networks, with different industry folks that are in tune with educational networks and education in general. So I don't really have a set agenda on what I'm looking for out of a working group. I thought it might be a good idea to discuss that here and see if there's any desire to form a working group, or literally, it doesn't even have to be necessarily a formal working group, just more or less a collaboration and a partnership going forward that, to spin ideas off of. Hey, we're having this potential problem, or we have this project, hey, we saw you're doing this, let's collaborate on that. So I see your point, and there's a lot of different ways that we could take this. But from my standpoint, I thought it would be great, especially with this open academic initiative that we're going through. And I have a lot of different research networks coming to me saying, hey, we want to spin up a slice to your OpenFlow network. Can we do that? And so, almost having a standard in place to be able to do that, to collaborate on an SDN going forward would be nice. So I know that really doesn't directly answer your question, but I don't think I can directly answer your question because there is a lot of different avenues that we can take this.
And just to stay on that, I mean, there's people here that I believe that you guys, you're interested in this from an IT utility standpoint. And
optics aren't really, viable for us. We don't have that much fiber, but I'm thinking even between our 2 data centers, how do we get access to the equipment to test it and kind of work with it?
Right. So, but you don't have research scientists
No,
at
this is
your
just pure IT,
institution. Okay? I mean, I'm at Pitt, so we've got a little bit of everything. And I'm trying to engage research faculty and bring to them opportunities for collaboration and opportunities for doing things that they don't either know about or haven't been able to find partners. So I'm interested in doing some sort of hookup with you in that regard. But not everybody is in the same position. You're gonna see somebody, Mike's interested in how to use this technology in the PenRed network.
Sure.
So that he can turn it into a service that the membership sees as a value add and possibly spur adoption and increase revenue.
See, I'm different because I could take Mike's ideas and I could turn around and say, you know what, this particular item is of interest to me and I haven't seen it implemented yet. Let me take that back and let me try to implement that in our test bed and collaborate with different researchers if it hasn't been done to either write papers, do some development, and actually spin this up into, you know, what could be a part of an overflow spec later on. So that's where I'm kind of, you know, I'm dancing a little bit in your question because I kind of have little hooks in almost all over the place.
So what you're saying is don't spin it off now. Don't multi-thread this thing.
I wouldn't. No, I would literally.
But what you're asking for, and we're discussing here, is something that could get pretty big and unwieldy, take up a lot of Kimber time, and maybe not be, I said not benefit anybody, but maybe hard to say how much time am I spending doing this and working on this thing and what's coming.
So Brian, the basic concept of where this started with Mike and others discussing what other services does Kimber want to do. And so the notion was have a working group within Kimber of what are the use cases and other services members would like to see. And then how do we go validate that? So we would set up a test bed, and seeing as SDN has a lot of attention, maybe we set up this SDN sandbox on the Kimber network. So if you're a Kimber member, you can access the sandbox and start this working group to go through what are the concepts, and then working with Mike on doing them, test them on the lab, and once they're vetted and solid, then be able to do it with them in production. So that was kind of where it started with what are the services members are looking for, and that is and the way to do that is a member working group, put together those sets of services, test them, validate them when they're solid, then put it in production. And kind of where it grew is there seems to be a lot of interest in SDN, obviously what Maris has done with incorporating into the curriculum. So once you have that sandbox that is a Kimber asset that a Kimber member is entitled to, there's obviously expanded use cases beyond the initial one. And I think that we're kind of what Mike is looking for is whether you want to call it a steering committee or working group to start figuring out what does make more sense. Is it more curriculum-oriented stuff that's interesting, or is it more what are the use cases they want and use this as an automation platform to be able to deliver them, test them, validate them, and then once they're validated, put up a client portal. So if you get two members agree to cross data centers for backing up to each other, they can go spin up bandwidth on demand to do that when they need it. Or if they're backing up already and you have an event, you can hit a button to bring on the bandwidth so you can download your backup. And maybe you're going to squish your I2 connection, squish KMAX and you don't care, and say, sorry guys, we're in a failure mode and we're turning up all of our bandwidth to be able to do a backup. So that was the question, what are the use cases and what's the environment that you can test and validate?
And there's a third part of that triangle. In Europe, especially in Germany, they start very early with their students. And industry and government are heavily involved in that triangle. In this test bed, having Advent IBM contribute and also have the academia part of it creates that triangle. We're very interested in what happens in, say, a sandbox here or a sandbox at Maris. We learn a lot from that. You're kind of leading the charge for us as industry vendors.
And that's where the support comes from. So Advent, Juniper, Copper River, we're prepared to support it. So it's not just throw it up the wall, but you guys need to drive it. But when you break something, we'll help fix it.
So the idea would there would be that you could have HP, Cisco, IBM switches, bring them in the test bed, ask them. They'll give you some switches probably just to throw in there. We'll provide heavily discounted optical gear. And you have this wonderful test bed that says you have all these different heterogeneous vendors. You have this optical infrastructure all orchestrated from one point, all from one controller. I mean,
And that's how our initial vision started as well. We wanted to do some interoperability testing because, you know, in the past, I haven't had much luck, you know, implementing, say, Juniper and Cisco and, you know, whoever else in the same network.
Have you done anything with the in-center lab out at IU?
I've done a couple things. I'm still in contact with Matt Davey at Talac now, but not recently. You know, and again, they're more interoperability. They've done some research on the side as well. They developed a couple applications and modules, but I haven't followed up with what they've been doing lately.
The only reason I bring it up is Kimber's got a strong linkage there with Global Knock.
Gotcha.
Global Knock does Kimber's Penrith launch.
Oh, really?
And
Okay.
and in-center is part of IU.
Right.
So there's a strong relationship there.
Now, obviously, you go to the next level, which scares all the vendors a lot. Go to white label switches. If you put an HP, Cisco, IBM in there, you're still buying the stack. So you practice with that. You've got your open flow agents on, you got your SDN controller. The next step is bring in some cheap white label switches from Scientific Micro out of Taiwan. 1/4 of the price of a normal switch. I mean, if you don't think that people are going that direction, just look at Amazon. I mean, instead of buying $1 billion worth of Cisco stuff, they spent $22 million on an SDN controller, open source, bought the developers, and bought white label switches. If you don't think the world is going that direction, I mean, unless someone proves that this stuff doesn't work, and so far I've been seeing it working, it's going to go there. And as much as Cisco and everyone else wants to fight it, I don't think they can. I think they're going to try to get you to keep buying that more expensive stuff when you've got this alternative here. But unless we prove it in a test bed, unless we get students working on it.
So how large is the group of students that you have working on the project now?
Six, seven students right now.
Okay. And is the curriculum developed that it would be available if we had a group of Kimber member students that were interested in this? Is it something that, obviously we have the hardware, we can replicate what you've done in a Sandbox and give them access to it over our network, but can we also kind of hand them the curriculum to start getting into this and start to learn and maybe replicate some of the things that you did, but it's a start to get them interested in it, to get them hands-on experience?
Sure. So I don't have a current curriculum that I can just turn over. What I am running is an SDN MOOC in the fall.
Okay.
That your students can be part of, and that's free. The SDN class that we were going to offer in the fall literally just got canceled yesterday. And the next phase of education would be, we actually house the Institute for Data Center Professionals, the IDTP.org program at Paris. And so there's development going on right now for a possible SDN track concentration along those lines. And that would start the first course of that would start in spring of next year.
That's the powerful stuff as far as education at this point. I think if we try to tackle let's create a curriculum, that gets into a whole
it does.
Bag of things that can be real difficult and can suck up a lot of time, and people just fall out of this thing. I mean, if you're going to have this SDN MOOC, and that would be something that I would go to my computer science department, my information sciences, and say, through KINBER, here's an opportunity for participation with a professor in a group at Marist. And oh yeah, by the way, we're trying to figure out with ADVA how we can exploit the Penrith network as part of it's in our facility for an SDN test bed. Let's talk, let's engage on this, that sort of thing. So, Mike, Pitt's in.
Okay.
He'll participate.
Yeah, I like that. I mean, the fact that it's an online learning, and everybody is able to join in and watch. And by the way, here's a free Sandbox to start working on, and it's managed from the KINBER level, so that we know what's going on in it. And then I think in parallel, we take some of these ideas of the network and more work with you directly on your existing team, because you're already familiar with I think to come to the idea of, virtualize your port with a new group of KINBER folks, or students from KINBER members, there might be quite the learning curve where we could throw these ideas at your group and kind of work with you on that track to see where that can go.
The attrition's high, everybody hears SDN and these students are off.
George, that same stuff
it's-
can be done at the community college too.
it's
You
a
guys can
constant,
take that same tack.
Evolution with these students. And what
Just
I
not have
found is it's
As a
typically
big
about a
department as I
2-month
do,
ramp up
you know,
for students.
with
That's
faculty
about it.
members that are already funded, may not even want to talk.
It's more or less.
It may be
here's the
easier for
overflow
you.
specs, here's what we've done, walk through some
Where
code,
adjuncts may
let's,
be very interesting. Yeah,
let's-
it may be,
let's cut to the chase.
easier for you.
And
My
just
guys
to,
may
just to
laugh
say,
at
these two students right here, Mary and
or
Zach,
scoff.
they had no networking course, nothing prior, they literally, they're sophomores right now. So when they were hired, they actually won a hackathon, which raised our interest in them for, an undergraduate computer science hackathon in their freshman year. So we said, hey, make a program. So they were kind of scapped up pretty quickly. And from that, but again, no networking experience, and they were able to develop something like this. So that says a lot right there about the power of SDN. And for the folks that have been out in the industry for quite some time, that also scares the absolute bejesus out of me. Because, if somebody with no networking knowledge can spin something like this up, geez, so.
Quick question about layer one. I assume that you need GMPLS controlled modem-based network, correct?
That's what we've been working with.
Okay. And then from a standpoint of topologies, whatever you can do with that mesh rings, more nodes in a ring.
The more nodes in a ring, the more flexibility you have for programmability. So,
Okay.
Related to that, and Zach and Mary may be better answers for this one, but your Avalanche controller, the Avalanche Optical OF, it doesn't actually need to have direct access to every node on the ring, every fiber node. You're running into a point at the OSC network and allowing the OSC and GMPLS protocols to propagate the change or find the location where it needs to be wavelength turned up. Did that make sense?
Can you ask it one more time?
So in other words, no.
You're basically, I think you're saying that you don't have to know anything about that layer one infrastructure, right? In that we're just.
That's what I'm asking, yeah, because the shelves will communicate with
That's
each other
right.
and let themselves know
Yeah.
what their capabilities are.
Absolutely.
Right. So you
And
write that stuff into a
That's
virtual.
what the abstraction is of the OF agent that does the conversion from OpenFlow to SNP. We've got a thing called link inserter because I've done the abstraction right, and now I can't see what's happening down there.
Yeah.
So I have a link inserter that reports back everything, if a link goes down, or a port goes down, or this goes down. So that on that switch, that looks like it's just in your data center, this port went dark. Well, really, that's port in data center A, they can't get to data center B, port to port anymore. And that tells us
Right.
what's going on as far as the topology, what's happening. And we use all the existing technology in our GMPLS control plane because we can't eliminate it. We'd love to. I'd love to dummy down my box and just give you an OpenFlow agent I can put on there, and you don't need my control plane anymore, and I just do for you. But they haven't done that. They haven't found a way to do it.
So, yeah, okay. You just need a single point of entry into a point where the network information is available, GMPLS and the OSC number.
But going back to your point for utilization and dispersion techniques, et cetera, as much information as you can actually pull up is better. Because then you can make more, better analytic decisions based upon how you're going to restrict that traffic over those wavelengths, et cetera.
What happens if you're running colored wavelengths, colored optics over just an amplified system?
It's a good question. We haven't used it, so I don't know.